We are building the Hungry Traveling Snake project from the YBite Python curriculum available at www.ybite.in. We have seen how we can move the snake tail so that it joins with the snake body and moves along with it. Was quite interesting. In fact, in this video, we look at an alternative implementation, which is always good to think about. Interestingly, this implementation is inspired from what we did in Scratch. Now, remember when we built this Scratch in the snake game in Scratch, we in fact had lists to store the X and Y positions of the snake head. And we did that in an inverted manner. What I mean is that the latest position was on the index, was the first index. Thereafter, we used a clone ID, which means every clone of the snake tail had a unique ID, and we used that ID to send the snake tail to the right position. Now, when I built this in Scratch, I had detailed explanations on why this works, some animations and stuff. So if you're interested, you can go and look at that. But let's see how we can make this approach or a similar approach work for us here in this project. The first thing I'm going to do is to create two lists, say xpos and ypos, and I'm going to insert in them the head position. Now remember, T is my turtle, which is the head. I'm inserting at position 0 because I really want this to be inverted. The insert in Python is in fact exactly same as insert in Scratch. The only difference being the indexing. Here it starts at 1, here it starts at 0. Now of course you can insert at any index, but we want to insert in the top, that's why it is 0. Let's first do this. Come into my code. I have commented out the parts which I was using in the other approach to eat those, to make those tails, let's say, move. But what I have done is to create two lists here, xpos and ypos, and I'm going to just, insert, let's say, the position of the turtle inside this list. So I just go and say xpos.insert at the 0th location, say t.xscore, and I'm going to say say pos.insert 0 t dot y core. Now please be careful with this, because if you make mistakes, these mistakes will percolate, and in fact almost in the same way as they used to do in Scratch. Now when I do this, remember the xpos and ypos will hold the position of the snake in an inverted manner. Let's just run this code once to make sure everything is correct and working, and indeed that's what I see. The code keeps running as always. Of course, right now the tail is not being formed because that part of the code has been removed. Let's see how we can move forward. Now let's use this timeline to sort of get a little bit deeper into how this game is working and how this list is getting updated. Remember, the game is basically working by making the snake move forward by 20 steps. Let's say I take only X here. Say the snake is going in a sleeping line. It moves in 20 steps every 0.1 seconds. Now the way the loop is set up right now, every time I move, I also update this list, which means that, say the snake was at 10, my list 0th position will be 10. 20 seconds, let's say 0.1 seconds later, snake moves to say 30. The head position list will have 30, then 0 because of the insert. Then it becomes 50, 30, 0. Now, a very, very important point to understand here is that list gets updated immediately after the head has moved to a new position. Now, why do I bring this up? Remember, the checking for the food being eaten happens before the head moves, which means that when I see the list at this point, just before it's been updated, in fact, I'm going to see list as, let's say, this. When I see the list at, let's say, at this point, just before the head has moved, I am in fact going to see this list. Now, this is very, 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 very. Having understood how this list head position evolves, let's see how we can use this now to place our tail at the right point. Now, remember, the tail really is the food items that are part of this list segments. All we really have to do is to send segment 0 to say head position 0, segment 1 to head position 1, and so on. But let's see this a little bit more step by step. When I, let's say check for the the food being eaten, say at this point, remember, let's say my list was, 10, head position was say 10. I eat a food, segment 0 will also go to 10 because I'm sending 0 index to 0 index here, which means there'll be a momentary overlap created, but the head will move away. The list will become 3010 and the overlap would have been resolved. Come the next opportunity, which is say 0.1 seconds later. Again, I check for the food being eaten. Let's say a food is indeed eaten. This food gets added to the list segment on index 1. It becomes food 2, food 4. But remember, my logic is I'll send 0 to the head position 0, 1 to the head position 1, which means 30 for food 2, 10 for food 4. Head is going to overlap with food 2 this case, but again the head moves away, overlap goes away, and the list updates. Next, when I come here, the list has become 50, 30, 10. Same logic applies. Perhaps this time food 0 has been eaten. That goes to position 2. Notice how the index here is becoming like the clone ID in Scratch. Very, very, very interesting. Think through this carefully, and let's go and try to implement this in the code. So I come in here and I say, okay, look, I just want to send the segment KK to the same position as, let's say, X pos KK and Y pos KK. So I just say, okay, for, let's say, KK in range, say len of, say, segments. Now, in this case, I don't have to distinguish between segment 0 and other segments because the same logic applies. I'm going to say segments, say segments, and KK dot go to X pos KK and say Y pos KK. Now this is how the index KK is being used, how we had used the clone ID in Scratch. Let's see this working. So my snake comes in, I try to, let's say, try to eat some food here. I go in, I click the, oops, missed this. I got this food, looks okay so far. I add in the food, kind of looks okay, but not really as smooth as what we were seeing earlier. Kind of adding up, kind of the tail is forming, but you can clearly see this is not as smooth as earlier. Let's sort of think through why this is happening and what we can, do to say fix this. In fact, the hint to solve this problem comes from the very first approach. Remember, in that approach, the segment 0 and head had a momentary overlap. Here we can do something similar. I can do this in the reverse order. So I'm just going to reverse this whole order, going all the way to, say, 0. That's why I put a stop of -1 here, because this must go all the way to 0 in steps of 1. Now this -1 is because I want this to happen all the way to the 0th segment. Now this code is more concise, and let's see this working. Notice it looks a lot more smoother now. It in fact works pretty much like the very first approach that we were doing, and see how, the code is in fact more concise. Let's do this a little bit again. Thinking through the different aspects of the dynamics of the game as we have done here, looking for ideas, applying them here will always help you, because that makes your game more robust and also the entire exercise more interesting. I hope you find this interesting. In general, if you think this way of learning is fun, look at our website, because we learn Python programming through such fun activities. Take care. Thank you so much. Bye bye.